Hello, my name is Ivana, and I'm a PhD student at the University of Waterloo in Canada. Today, I will be presenting research on communication emergence in multi-agent reinforcement learning that I did in collaboration with Eser Aygün and Doina Precup at DeepMind. As we all know, the world's languages are remarkably diverse. They're also shaped by a variety of factors, such as culture, physical environments, and neurocognitive mechanisms. Understanding how some of these factors affect language and language emergence more generally can be quite challenging. One popular method to study emergence of communication systems is through experimental paradigms where children or adults need to emerge novel communication signals. Another method are agent-based language simulations, particularly popular in artificial intelligence. In recent years, this has also been a well-studied topic in multi-agent reinforcement learning. These setups often use referential signaling games, such as, for example, the signaling game of Lewis, where the sender agent and the receiver agent need to coordinate their actions to achieve a common goal. In this research project, we extended the signaling game as a navigation game to study characteristics of the communication protocol when agents are allowed to interact with the environment. The setup consists of a one or multiple senders and a single receiver. The sender sees the goal location in a grid world environment. It selects a message, in this case, a single symbol from a fixed vocabulary, and stays silent until the end of the episode. The receiver does not see the goal location, but it sees its own position and the message it got from the sender. It uses those two pieces of information to choose a navigation action. It will perform these movement actions until it reaches the goal location or gets terminated. If it reaches the goal, then all agents, including the sender, are rewarded. Both agents are reinforcement learning agents. Sender is a bandit, selecting one out of n actions, and receiver is a Q-learning agent. In the experiments, we vary the number of senders between 1 and 5. If a setup has m senders, the receiver sees m messages. Also, senders are not aware of each other's messages. The only information shared among them is the reward at the end. We also vary the number of messages available to each sender and the grid world environments those agents are situated in, so that one setup of senders and a receiver is placed in one out of these 5 environments. To evaluate performance of agents on this task, we first look into average return they achieved during training. Based on training curves reaching the theoretical maximum value, we conclude they learned to successfully perform the task. We also investigated how the number of messages affects agents' performance on the task. We noticed a common pattern in these curves in all environments: an increase in performance up to a certain point, and after that, saturation. We attribute this to the capacity which is sufficient for agents to solve the task optimally. Finally, we examined the communication protocol by analyzing the meaning of messages. To do so, we looked at sender policies and show here a few selected examples. We observed that messages encode spatially meaningful concepts. For example, they're used to refer to spatial aspects in the environment, such as left or right, or upper left room. When we have 2 or more senders, we start to observe emergence of structure. For example, in the setup here with 2 senders, we observe highly coordinated allocation of messages, where messages emitted by sender 1 partition space according to the x-axis, and those of the other according to the y-axis. This phenomenon emerges even though senders are unaware of each other's messages, and we argue that this is also a basic form of compositional structure, where the meaning of the whole message depends on the meaning of individual symbols. As well, we claim that it emerges with minimal assumptions. Let me know if you'd like to know more about this project or if you have any questions. Thank you for stopping by.